Okay, 6.1, discrete continuous variables. This was the most missed question. I was really confused about this, but when I went over this on Friday, I think a lot of students said that there was this question down here at the bottom that they just didn't see. And so when you checked it, it counted it wrong, which made me feel a lot better. One of the higher ones was still one of these multiple choice ones. Guys, these are the type that you're going to see right on the test. Choose an American household at random. Let the random variable X be the number of cars, including the SUVs they own, given the probability distribution, given the distribution if we ignore the few households that own more than 5 cars. Okay, so more than 5 cars. What percent of the households have a number of cars within 2 standard deviations of the mean? So what you should have done on that one, you should have calculated the mean. Calculate the mean by doing, well, you use your calculator, do L1, L2, calculate X bar, and then you had to calculate the standard deviation. So once you calculated the mean and then calculated the standard deviation, add 2 of these to this and subtract 2 of these to this. And I think it was everything from 4. I think it was all those. I think. I'm going from memory because I think it was, no, maybe it was 3 point something. 3 point something. And negative something, I think. Either way, though, but you had to calculate the mean and the standard deviation, then add 2 of those to it, and subtract 2 of those to it, and then add those probabilities that are within that. Okay? Delete. The next multiple choice right below it. That was 63%, not too bad. This one was, this has been highly missed on all of them. You got 52 cards, 4 aces. So 4 out of the 52, you win $10. So X is 10, and that's the probability of X. And then -1 if you don't. And so that's what's left are the 48 cards out of the 52. And so this times this plus this times this will calculate the mean. And that's what you expect to win or lose. And I think it was -15. So you would expect to lose 15 cents on the average. I mean, if you played over and over and over and over again, you'd lose 15 cents for playing that game. Not too bad odds. However, if you won one, I'd stop playing. Okay, click, click. All right, we're good. Here we go. 6.2. 6.2. This used to be pretty bad, but I fixed it, I think. A lot, just like 6.1, it's a lot of repeat stuff. A lot of repeat stuff. Y'all remember in chapter 2, somewhere where I took all of your test scores and like added 5 points? And when you added 5 points, what that did is moved everything 5 points down. So it moved the center, but it did not change the spread. It did not change the shape. So kind of like that. If I took your test score and I multiplied it by 2, then that moved it down by that, but it also spread it out. So multiplication affected the spread and the center, but neither one of them, nothing affected the shape. And if you can remember those rules from chapter 2, a lot of that comes up to play today. Okay? So here we go. Transforming a random variable. In chapter 2, we studied the effects of transforming the linear shape, center, and variability of the data, right? Remember, adding or subtracting a constant, the center adds or subtracts that center, right? So if I added something to every piece of data, it added it to the center. If I subtracted something to every piece of that data, it subtracted it to the center, okay? So adding or subtracting a constant to every observation changed the center, that same addition or subtraction. However, the variability did not change, and the shape did not change. All it did is just shift it. Shifts the data if you wanted to kind of picture that on the number line. If it was a graph, all it would do is move that graph down or to the left. It doesn't make it bigger, it doesn't make it smaller, and it doesn't change the shape of it. All it does is shift it. So addition and subtraction, all it did is change the center. And the centers, of course, is the median, the mean. It would change, I guess that was it, the median and the mean. It changed percentiles. the values of the percentiles. Okay? Again, that was all from chapter 2. Nothing new there, I hope. Multiplying or dividing changed that center, that same multiplication or division. It did also change the variability by that same multiplication or division. However, it does not change the shape somewhat, right? It changed the spread, which changes the shape, but it doesn't change the look of the shape. So if it's symmetric or skewed to the right, it's still skewed to the right. It's just stretched out further or shrunk in further. So addition and subtraction changes the center, and that's it. Multiplication division changes the center and the spread. That was, if you guys can remember, that's one of the highly missed questions, is because we gave you a formula changing Celsius to Fahrenheit or something. And you guys plug and chug, and you did it for the center, which is okay, but you're not supposed to do it for the spread because the addition and subtraction didn't affect it. We'll do that in just a second.
So both of them didn't change the shape?
Neither one of them changes shape. Once the shape's established, the shape's there. Okay, so some of you probably, okay, well, we did all that stuff in chapter 2. Why are we pulling this back up in chapter 6 now? Whatever happens here, this is the effects of linear on the distribution of data, okay? Well, now what are we talking about? We're talking about probability distributions. The same thing happens. If I'm adding or subtracting to it, it adds or subtracts to it. But it only changes the center. It doesn't change the shape. It doesn't change the spread. If I'm multiplying or dividing, it's going to change both the center and the spread. However, it will not change the shape. This is what's going to come up in just a second. So this is probability distributions. Don't write all this down again because it's the exact same thing. Center adds or subtract. Variability does not change. Shape does not change. Center adds or subtract. Oh, that's not even supposed to say add or subtract. It's supposed to multiply or divide. I didn't see. Don't copy that at all. That's bad. All right, here we go. Looky, look. In a large introductory stats class, the course X of a randomly selected student worth 50 points can be modeled by a normal distribution with a mean of 35. Your notes are going to bounce around a little bit again today. I apologize for that, but I think I've made it simpler by removing a lot of stuff. Where'd you go? There you are. Okay, so we got a normal distribution with a mean of 35, standard deviation 5. Just a habit I get into. Anytime they tell me that, I draw it. Due to a difficult question on the test, the professor decides to add 5 points to every student's test score. Let Y be the scaled test score. So recognize this. This was X. This is the distribution of X. X is a normal distribution with a standard deviation 5 and a mean of 35. Due to a difficult question, to add 5 points to every test score, let Y be the scaled test score. Describe the distribution of Y. Remember, when you describe the distribution, you better talk about the shape, center, and spread. And if I only add 5 points, guess what my shape's going to still be? Normal. Guess what my spread's still going to be? 5. But now my center is now going to, instead of be at 35, it's now going to be at 40. So now how we need to show this, here's what I would show. The mean of Y is equal to the mean of X plus 5. Okay? I forgot to hit start. I'll just do it next hour. The mean of X plus 5, which is 40. Okay? So again, this is how you need to show this stuff. The standard deviation of Y is equal to the standard deviation of X, which is still equal to 5, because it's not going to change. And then the shape of Y will be, it says normal. I like to put approximately. You're never wrong by putting approximately in front of it, and sometimes you're wrong if you don't put it. I think you're being okay because it just says normal here. Yes, no, maybe? Good enough? I didn't really need to draw that, other than that's just a huge habit of mine. I could have drawn Y, I guess. What'd they do? Shape, approximately normal, center, mu of y is equal to mu of x plus 5 equal to 40. Standard deviation of y is equal to standard deviation of x, which is equal to 5. Easy peasy lemon squeezy. Here I have El Dorado Community College. Considers a student to be full-time if he or she is taking between 12 and 18 units. So this is somewhere in your notes, I'm guessing. The number of units that a randomly El Dorado student is taking follows this distribution. So here's 12 units at 25%, 13's at 10, 14's at 5, 15's at 30, 16's at 10, 17's at 5, and 18's at 15. Notice that the 12 and the 15 and the 18 are the highest. That's because your college hours are typically 3 hours long. And so this would be 4 classes, this would be 5 classes, and that'd be 6 classes. And then sometimes you get some labs, and that's why the hours are a little bit, but that's why it's kind of hard to get 14 and 17 hours. Because you got to throw some PEs in there or some kind of stuff. Anyway, who cares? At the right is a histogram of that, and we should be able to at least see that histogram. We kind of know that this is the highest, or excuse me, that's the highest. This is next, there's a next, so I kind of have 3 humps. It looks somewhat symmetric. I got 3 humps, yada, yada, yada. They tell me the mean, and they tell me the standard deviation. That's very common for them to tell us that. If they didn't tell us that, we know how to find it from 6.1. This times this plus this times this plus this times this finds the mean, and then we get a really crazy formula to find the standard deviation. But again, most of the time they'll give it to us. At El Dorado Community College, the tuition for a full-time student is $50 per unit. That is T equals 50X. If you can't figure this out, they'll kind of give you a formula. Describe the distribution of T. All right, T is symmetric. With 3 humps. I don't know how you want to say that. That's how I'll say it.
Will they take like 3 humps?
Sure, I think. I don't know. I've never seen 3 humps. I think they will. What else would you say besides 3 humps? 3 peaks? Okay. You and your fancy little English. Leave it to the non-English guy, whatever. The center of T is equal to the center of X times 50. And the center of T is 14.5. Uh-oh, sorry. Let me clean that up. 14.65 times 50. And whatever that equals is your new center. And then the standard deviation of T is equal to the standard deviation of X times 50, because multiplication affects both. And the standard deviation was 2.056 times 50. I'll clean it up so that you guys can read it. Non-hieroglyphics. What did they say? Oh, it is. They said 3 peaks. You little nerds. Put your peaks if you want. I'm going to put humps. A really special looking camel. Everybody okay with that? Good? Easy? Again, there's no what's really new about this? Really nothing, other than we're tying in data, which is what we did in chapter 2, into probability distributions. Okay? The same thing happens to both. Luckily. Clicky. This is the one where a lot of you guys missed on the test. And then because we're ingrained in our stinking heads, any linear transformation or anything linear, we plug and chug. We plug and chug. And we just get into the habit of doing that. One brand of baby bathtubs comes with a dial to set the water temperature. When the baby safe setting is set, the temperature X of the water randomly follows a normal distribution with a mean of 34. So X has a normal distribution with a mean of 34 and a standard deviation of 2. You can write it like that also, as opposed to drawing pictures. If you write a big N parentheses, something, comma, something, that's always normal, mean, standard deviation. Let Y be the water temperature in Fahrenheit. Recall that Fahrenheit is equal to 32 plus 9/5 C. Find the mean of y. Well, the mean of y is equal to the mean of x multiplied by 9/5, but we're also adding the 32. And the mean of x was 34. So 34 times 9/5 plus 32. Everybody okay with that? I'll give you that answer in just a second. Calculate and interpret the standard deviation of y, and this is the one we just get in such a habit. The standard deviation of y is equal to the standard deviation of x multiplied by 9/5, but that's it. Don't add the 32 because addition doesn't affect it. But we get in such a habit of plugging and chugging into my formulas. That's what we try to do, but you don't. The 32 has nothing to do with the standard deviation. And so that was 2 times 9/5, which is 18/5 or whatever else. Interpret that. The temperature of the water typically deviates, whatever that is, from the mean. 93.2 is what you'll get there. 32 plus 9/5, 34s. Standard deviation you'll get is 3.6. 9/5 times 2. If we randomly select many days when the dial is set to baby safe, the temperature of the bath typically varies, typically deviates, tends to fluctuate around the mean of 93.2, 3.6 degrees, whatever you got to do. Don't forget these interpretations. Don't forget them. Yes, no, maybe? That's half this lesson, which is really nothing new. Kind of nice. Okay, let that soak up. I'm going to let you guys quit writing when you get there, because then I want to chit chat for just a little bit, and then we'll finish the lesson. I like to give the scenario first before I talk about it. So, whole, part, whole is the way I do this. Got a basket of oranges over here. Got a basket of apples over there, and I go to the store once a week and I buy some oranges and I buy some apples to take home. That's what we eat for snacks. Good enough? On the average, I buy 5 oranges. On the average, I buy 5, 1 for each day. On the average, I buy 3 apples. On the average. So I got 2 different distributions or 2 different variables. Okay with that? If I randomly or on the average buy 5 over here and on the average I buy 3 over here, on the average together I happen to buy how many pieces of fruit? 8. Good enough? Whatever the average is over there and whatever the average is over here, if you're going to combine it together by adding them, then the average is typically, you're just going to add those 2 together. And no students have no issues with this whatsoever. That makes sense. It makes sense. Sometimes I like to compare the test scores of tests. I'm way behind on your tests. I know that. Please be patient with me. You guys have been wonderful about that. I have not received but 1 email about it. Thank you guys. This week I'm getting it done, I promise. I got a lot done yesterday, but it didn't get done. Okay, so anyway, I like to compare test scores. So I have you guys' test score. I have an average of your test score and I have a standard deviation. So I have an average of your test score. I'll care about the average right now. And then I have another class that I have their average. And sometimes I don't want to add those 2 because that doesn't make any sense to add the 2 test scores. I like to subtract the 2 test scores. So let's say that the average of this test score was an 86 and the average test scores of theirs was an 83. Typically, that means what? If I grab somebody's from this test and somebody's from this, it should be about 3 points difference. Good enough? Subtract the 2. Good? Yay? Well, that's what we're going to be talking about. We're going to be talking about combining variables together, combining distributions together. And if I combine them together, the means are really, really easy. We take the means and we just add them, or we take them and we subtract them, depends on if we want the addition or if we want the subtraction. The standard deviations are what gets us. We don't add standard deviations ever, ever, never, ever, ever, never, ever. And if you can get that through your heads, you're good. Here we go. Yes, but we just don't add standard deviations. Okay, means. Here we go. This is what I just talked about, the means. The mean of the sum of the random variables. So I got some random variable here, apples, and some random variable over here, oranges. And I want to sum those together. Yes, I probably jumped quite a bit in your notes. I figured, why give you 15 examples of something that you already know how to do when I could give you your homework and you could work those examples. That's why I skipped a bunch of it. Okay, y'all good with that? So in order to do that, if I had two random variables, x and y, apples, oranges, the sum of x's and y's is the sum of the individual means. That looks a lot worse than it is, but let me just tell you that the sum of the means is equal to the sum of the x plus the average of the y. Good enough? Whatever the average of the x is and whatever the average of the y is, if I want the sum of those two, I'm just going to take the sum of the two means. The sum of the means is the sum of the two means. That's how they showed it. Mu of s is equal to mu of x plus y. I don't really like this one as much as I like mu of x plus the mu of y. Easy peasy, lemon squeezy. I hope that, like I said, students have no issues with this whatsoever. It almost makes sense. If I typically buy 5 oranges and I typically buy 3 apples, I typically buy 8 pieces of fruit. Or I typically buy 2 pieces more oranges. And then the subtraction is the same way. Mu sub d is mu of x minus mu of y. Subtract the two. Subtract the two. Again, this is not that big of an issue. Most students have no issues with this whatsoever. If I want this average and I have this average and I want the sum of the two averages, we just average the two together. On the average, that's what we get. On the average, that's what we get. Let me throw in a quick example for you. Y'all remember, I know this has been a while ago, for you guys it's been real long. We had Pete took these Jeep tours, right? And he made so much money if it was 2 people, and he had 2 people up to 6 people. 2 people up to 6 people. Now this is the number of people, this is not the amount of money. The one you had was the amount of money. But it was still the 15%, this was 25, 35, yada, 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 yada. I can find the mean of this data, right? Why would I call that Y? Let's call that P, mean of Pete. We can find that mean pretty easily from 6.1, okay? Pete has a sister, Erin. Erin also does Jeep tours. Erin can only go from 2 to 5 people. Her Jeep's not as big as Pete's. Whatever. Okay with that? I can find the average of Erin pretty easily. This times this plus this times this plus that times that plus that times that, and I have the average there. Good enough? I'm telling you that Pete's average is 3.75 with a standard deviation of 1 point, but I don't care about that yet. Don't try to think about that yet. And I can tell you that Erin's average is 310. Don't care about that. So Pete carries more people on the average than Erin does. Good enough? Their question is, what is the sum of the randomly number of passengers that Pete and Erin will have on their tours on a randomly selected day? And so the sum is equal to the mean of Pete plus the mean of Erin. I think they actually used X's and Y's. I would probably use E and P's. And I would go down here to 3.75 plus 3.10. And you guys got calculators. I can actually do that. That's 6.85 passengers on a randomly selected trip. Yep.
On our paper, it says what's the total number of passengers they will have on a randomly selected day?
Same.
Would that be the same thing?
Same. Yep. The total. Yep. Good enough? On the average, the total number of passengers that they will take between a trip is 6.85 passengers. He normally gets 3.75. She normally gets 3.10. They normally get 6.85 together. Okay with that? If I wanted to know how many more average Pete then gets, I would just subtract those two and realize that Pete gets 0.65 more passengers. Do understand that sometimes you might get a negative on that. Okay, if I subtracted Pete from Aaron, you would get negative 0.65. It still tells you the same thing, that Pete has more than Aaron, or you could say that Aaron has less than Pete. Either way, it still tells you the same number. So if somebody decides to flip-flop that and subtract it wrong way, it still tells you the same information. That's why they typically ask you to interpret it. Everybody okay with that? Pretty easy? Not bad? I don't want to seem that too hard. Shouldn't be. Pete charges $150 per passenger. Now we're starting to combine some of this stuff we're learning. Pete charges $150 per passenger. Aaron charges $175. Huh. Aaron charges more. Imagine that. Female. Good for her. C be the amount of money that Pete makes. E be the amount of money that Aaron makes. From our earlier work, we know that mu sub C, this is how much Pete normally makes on a trip, $562.50. Aaron normally makes $542.50, even though she charges more. Ha, 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 ha. She doesn't make as much. I want to find out how much money they make together, because at the end of the day, they're brothers and sisters and they share. And that's what we should do. And so all we have to do is, if you want to know, and they tell you, define C or S as C plus E. Why they use C instead of P, I don't know. They should have used P, because P is Pete. We're just going to add those two together, and we're going to see that that's going to be the combined total amount of money. Mu sub S is equal to mu sub C plus mu sub E. 562.50 plus 542.50. Show your work, show that step, guys, show that mathematical operations. I have seen AP give students credit even with a wrong number right there. Okay? Because they know what to do, but if you just have this down here by naked, they may not give you credit. Pete and Aaron expect to collect a total of $11.05 per day on average over many randomly selected days. Good enough? Any questions? If I wanted to know the difference, Pete expects to make $20 more than Aaron. Or Aaron expects to make 20 less than Pete. Depends on how you want to subtract that either way. Okay, questions, questions, questions. I don't want to make this seem too obvious, but it is pretty obvious. Most students have no issues combining data with the means. If I'm adding them, I'm going to add them. If I got to multiply them, I'm going to multiply them and then add them. Whatever I got to do, I'm going to do to add those means. Sometimes you have to do both. Sometimes you have to do something in this data and do something in this data and then add them. I don't think you'll ever multiply the two data together. I don't think there's ever a reason. It's always a sum or difference. Now, this is the one, if I can get it through your heads, I got to try to get it through your heads. We don't ever add standard deviations, although they're going to really want you to try to do that. Don't add standard deviations. Don't. You can add variances. Remember what the variance is? Variance is the standard deviation squared. So whatever this standard deviation is, 2, whatever the standard deviation is over there, 3, you got to square this bad boy, square that bad boy, then you can add them. After you square them, you can add them, and then you got to take the square root back out of it. Okay? For any two independent random variables, x and y, the sum of x and the variance is squared is equal to the standard the variance of the first one plus the variance of the second one. This is the sum now. This is the sum. This is the sum. So you have to take the two standard deviations and square them. Why? Because that's what I'm telling you to do. Because you want the right answer. But why? Because you want the right answer. But what if I don't? Then you will get the wrong answer. I don't know why. It just that's the way you have to do it. Somebody else a whole lot smarter than me said this is what you have to do. And then, of course, we typically don't want the variance. We typically want the standard deviation, so we square root both sides. I do want to make sure, I know most of you guys are mathematical people, do understand that, well, why am I squaring each one of them and then adding them and then taking the square root out of it? Why don't I just add the two? Because that's not the same. It does not equal that plus that. It doesn't. That is not true. That does not mathematically work. If this was 2 squared, this would be 4. And if this was 3 squared, that'd be 9. And 4 plus 9 is the square root of 13. And 2 plus 3 is 5. And that's nowhere close to the square root of 13. It has to do with kind of goes back to the old, that's why x plus 2 squared is not x squared plus 4. Right? You got the outer and inner stuff. Squaring things makes things different. Squaring pluses makes things different. We're squaring first, then adding, just to make sure mathematically you understand that. Y'all okay? Add variances, add variances, add variances, add variances, add variances, add variances. Always add variances. Always add variances. Add. Always. Why do I say always? I hadn't done subtraction yet. Guess what? Subtraction, you're still going to add them. And that's the one we really mess up on. Caution, never ever add standard deviations. I can't get it through your heads enough. Subtraction. In subtraction, if I want to subtract those, I still add. Guys, there's no way to make a distribution over here, whatever it is, and this distribution over here. If I'm going to combine that, there's no way for that combined distribution to be smaller. It's got to be more spread out. Because you got a distribution over here that's somewhat spread out, and this distribution over here that's somewhat spread out. If I'm combining it, even if I'm subtracting them, there's no way to make it a small. Like if this standard deviation was 2 and this standard deviation was 2, like there's no standard deviation. No, that doesn't make any sense at all. You're always going to add. You're always going to add them, no matter if you're subtracting them, no matter if you're adding them. If you guys can remember that, I'm telling you that's at least 4 questions on the AP test. At least. Go ahead.
So if it asks for like the difference of 2,
Yep.
You just like add the difference with us.
Yep.
Like,
Add the
same answer
same answer for
for addition.
addition and subtraction. For the variance or for the standard deviation. For the spread. So even if we are subtracting, sorry, dadgummit. Fix. Add the variances of the individuals. Always add. And that's why I say always add variances. Never, ever subtract. Never subtract. There's going to be a multiple choice question. You're going to see subtraction on there and mark it off. It's wrong. You'll never, ever add them.
Will it ask you to like justify?
Nope. Well, I mean, if it's a free response. But you're just going to just do it just like that. I mean.
Okay, so you're not going to like
No. Show it mathematically. Everybody else okay? Anything? Example? Here we go. Pete charges 150 per passenger. Aaron charges 175. Let C be the amount of money that Pete collects. Let E be the amount of money that Aaron collects. We know that the standard deviation of C is 163.46 and the standard deviation of E is 165.3. Aaron's standard deviation is more than Pete's, not by much. Assume that these 2 random variables are independent. We will have to assume that a lot of times. If they're dependent, we can't do any of this stuff. Define D as C minus E. Earlier, we found that mu sub D is $20. I didn't find that, but you guys subtracted that in your head pretty easily, and you found the difference to be $20. Pete normally makes $20 more than Aaron. Calculate and interpret the standard deviation of D. And so the standard deviation of D is equal to the standard deviation, or the variance of C plus the variance of E, which is equal to 163.46 squared. Holy cow, we're getting some big numbers. Plus 165.03 squared. And then I got to take the whole square root of that thing. And so you're going to go to your little calculator and you're going to hit a 1 and a 63.46 squared plus 165.03 squared entered to the 1/2 power, or square root the thing, or whatever you guys got to do to find the square root of that. And when you do, you're going to get, remember now, this is the sum of the variances. That's why we got to take the square root. That's $53,500. There's no way the variance is $53,000 if the difference is $20. However, the variance, or the standard deviation, is $232. The difference of Pete minus Aaron in the amount of collected on a randomly selected day typically varies $232.28. A lot of times, guys, we just look at the answers and we don't really think about it. Think about that standard deviation of 232 and the mean's 20. What does that mean? If the mean is 20, like Pete typically earns $20 more, but the standard deviation is $200 away from that 20, there's probably a lot of days that Aaron makes more than Pete. Y'all kind of make sense on that? With that being 20, and I'm going 200 away this way and 200 away that way, when I get to 200 this way, I mean at 20, I'm at zero. So I got another $200 and I got a whole lot of negatives. Just kind of picture that. Just think about that kind of stuff every once in a while. See if it makes sense. If it doesn't make sense, you've probably done something wrong. I don't think it's typically going to vary $53,000. 200 is still quite a bit. All right, y'all good? Anything? I think we're the diameter of the, oh, this is a good question. I remember it now. The diameter of a large drink cup at a fast food restaurant follows a normal distribution. Normal distribution, cup, normal distribution with a mean of 3.96 and a standard deviation of 0.01. Wow, that's a really small standard deviation. That's probably a good thing, because we don't want our cups varying a whole lot, I'm guessing, right? We want those to be pretty darn consistent, so it's a good thing. Normal distribution, 3.96, 0.01. The diameter of a lid follows a normal distribution with a mean. Please be bigger than 3.96. It's 3.98. Why do we want the lid bigger than the cup? So it fits. 3.98 with the standard deviation of 0.02. They need a better quality control manager. Now, I can already see with a standard deviation of 2, this fluctuates 2 pretty consistently. In fact, 68% of the time, it fluctuates between 2. 95% of the time, it fluctuates between 4, or 4 here and actually 8. There's going to be some of those lids that don't fit. Assume that A, L, and C are independent random variables. Let the random variable D be L minus C. Oh, crap. I put C over here and L over there. That's all right. D is equal to L minus C. The difference between the diameter and the cup's diameter. Describe the distribution of D. Well, I went through fast slides and I didn't help you on this. But I'm on a common census, I would hope. If this distribution over here is approximately normally distributed, or normally distributed, and that distribution over there is normally distributed, and I'm going to subtract those two, guess what? It's going to still be normally distributed. Because what affects shape? Nothing. Nothing. Now, if this one's skewed right and that one's normal, now I'm not too sure what happens when I put it together. It's probably more normalish, but still a little skewed. But if this one's normal and this one's normal and I put it together, it's going to be normal. If this one's uniform and this one's uniform and I put it together, I don't know what happens. If this one's skewed right and that one's skewed left, I don't know what happens. But if this is normal and this one's normal and I put it together, it's going to be normal. Good? So, describe that distribution. Well, it will be normally distributed. Normally distributed. Why? Because this one's normal and this one's normal, and I'm putting them two normals together, and I put two normals together, it's going to be normal. With the center at 3.98 minus 3.96. I'll probably go ahead and show that. 3.98 minus 3.96, that's 0.02. So I got a center at 0.02 and a standard deviation of the difference of 0.02 squared plus 0.01 squared, square rooted. And then you got a calculator that does all that. Who has a question about this so far? Okay, so I have a mean and I have a standard deviation and I have a shape of the difference. Shape, normal, center, 0.02. Standard deviation of 0.0224. I'll go ahead and carry that out a little bit just so I can try to distinguish the difference. If I was doing this on the test, so I'd probably put up 0.02. Good enough for that? Beautiful. Beautiful. For the lid to fit on the cup, the value of L has to be larger than the value of C. Duh. But it can't be more than 0.06. Because it's too big, it won't fit. Find the probability that a randomly selected lid will fit. Well, it can't be more than 0.06. But it has to be bigger than 0. It has to be bigger than 0 because if it's negative, it's not going to fit. It said it must be bigger than the cup. So I need the area from 0 to 0.06. Normal CDF, 0 to 0.06 with a mean of 0.02 and a standard deviation of 0.0224. Easy. Once you got all that stuff down, it's down to your calculator, it's down to Desmos or whatever you guys want to use to figure out what that area is. From 0 to 0.06. Good enough with that? I'll tell you that that answer is, there's a nice pretty picture over there. There's a z-score. We don't care about z-scores, although you should remember the z-score is, right, 1.07 and negative point, who cares, 77%, 0.7763. So you should probably have a probability statement, and x is less than 0.06, but greater than 0. Something like that with a nice pretty picture like you got already. They already hand fed us all that information. Wow, 77% fit. That's not a really good number. 3 out of every 4. 3 out of every 4 fit. I mean, there's many times my whole family goes through a drive-through and we get 4 drinks. That means one of those lids didn't fit. That's not real good. Yes, no, maybe? Pretty good question. You got one on your homework pretty similar to that. They're trying to put a peg into a furniture hole or something. And the peg's normally distributed and the hole's normally distributed and the peg sometimes fit and sometimes the peg doesn't fit. And sometimes it's too loose. Click. I hope that you can describe the effect of adding or subtracting. I hope that you can, or multiplying or dividing. Calculate the mean and standard deviation. Find probabilities using normal distributions. I told you guys this is a lot of repeat. 6.3 is not. But we have 6.3 left. We're going to review a couple of days. We're going to put all this stuff together. You're going to get your test back sometime. Yay? Yay? Is that assigned? Shucks. I thought I did all of them. Yes. It's on the calendar. I don't know. It's the day before. I think we're doing it before Thanksgiving. Just before Thanksgiving. 6, 3, 2, 6, 2, 6, 2, 6, 2, 0 B. I didn't do it. Dadgummit. Duplicate. This is first hour. I'll fix all that later. Save. Oh, I got it. No, it did it. All right, should be there now, guys.
So you're coming to my class now?
No. Cherika said she was going to hold you guys longer.
Yes, sir. You tell me what you need to do. Okay. Or you can do it in class one day or whatever, after school, before, whatever best for you. Of course you can make it up. Knucklehead. I always give people make a chance up and make tests. Just tell me what fits your schedule ready. Tell me when you're ready and we'll do it. If your schedule doesn't match my schedule, and I'll find the schedule that does, or we'll coordinate. Just send me an email and we'll figure it out. What?
I assume the test is next Wednesday.
Ours?
It's like, isn't it Monday?
It's Friday.
Friday is the B day next week. Oh, it's this Friday. So it would be Wednesday next week.
Oh, yeah, because we have an extra B day. Yeah. Wednesday, Thursday.
Yeah, I was going to say, you know, put that on Monday.
Oh, it's not Monday. It's not Monday.
That would not be good. I would say Saturday.
You okay?
What time is it?
55. Oh, get too fat. Sorry. No, it was my fault. You moved for me. You moved for me. I just didn't get through enough. I wasn't agile enough. Did you have a good weekend? Good.
Yeah, no, I'm gonna try.
We had a sub in, huh? Had to call in a relief. Are you?
Yeah. I've like never done any ice skills before, but I think it'll be fine. I just wish I had a little longer length.
They wouldn't call on you if they didn't think you could do it.
Yeah, so I guess that's good.
That's right. That's exactly right. There's a reason why they chose you. So.
I'm glad Kate's in the United States, or his United States suck. Watch her.
Enjoy it, make it fun, knock it out.
I told I'm gonna try. Who wants to make
I bet I know you will.
I'll let him sign up.
I will.
I'll send you the link to it first. So you can sign up for it.
Good weekend? He's locked in. Can't interrupt that. Gentlemen,
Hey,
good weekend?
decent? Yeah. Yep.
Cool. You smile at me. It's just Monday.
I know.
Oh my gosh, I need to change my clock. It says it's 3:12 p.m.
On your MacBook? Yeah. What?
Why does it not automatically?
It's not.
I can't wait till I get my computer because what do you mean you guys have MacBooks? I have my Chromebook. Figure out how to change this.
What is that?
Flavored water.
Yeah.
Oh, I have to update it.
Pomegranate berry, or I don't know. They all taste the same to me.
They taste the same.
I mean, the lemonade doesn't, but
I was about to say.
all the berries do. Okay, while y'all are working, I probably ought to grade some tests.
It might honestly be 999 because it's like 5 standard deviations. Wait, no, it's level 0.0.
We have to get a grade of like 1.3. And
0.3.
I could through and I said that.
Wait, why?
It's literally like
I need to remember how to do that. I don't know.
I know, but like
Yeah, and then Alan. Smiling, Axel got perfume. So then look. Are all these like foreign guys just like Miami? No. Elma kept rocking Kerwa.
I wish it was so
Hi, when you're wait, so you Jazzy, I went 7
What do you mean? Because you're not good.
Is it the sub for all parents reaching campuses for campuses? Or is it the average? For 18,
Yes.
that's
So, that's effectively here.
both of them are good and easy to
We can combine it. How is she gonna carry anyone out of her party? She's strong, but like a grown ass man. Does she want to be like a paramedic? No. She wants to be a firefighter. They don't post these for my dream job at I just need to start for like
That's like, yeah.
that'd be my Aren't you going?
Because you have to swear. Okay, so I got her all. You know, actually, no, it's not super great because she actually wanted to do that. Oh, this is actually evil. This was you'll find out how to pass.
Yeah, I mean, it's like 12 or 13.
You're gonna be like, we didn't blow risk taking on a bad one.
First, so you put it on your and that's
You
like
might take
that's
someone else. Wait, what did you say? I lost. Are you coding the database?
and that's a nice picture.
You think Indians have fun?
Did I show you my fit?
No,
You need to do like a full. Look at my outfit. But I took some of my mom.
You want to know the true many things.
You also act.
I think one of going to their value. This in my head. 44. That's what I think.